Welcome to the very first video lecture for the MPP math class. As I mentioned in class, students are in very different places, and so I encourage you to use this lecture according to your own needs. For some of you, I suspect that this will be complete review. You are welcome to move very quickly through. Just check the example problems and move on. But for some of you, I suspect this will be a helpful reinforcing of some of the things that you saw in math camp. So with that said, we're going to quickly move through some of the more basic rules that are used in algebra and then spend a little more time doing some practice of the types of things that we tend to see people having trouble with. The first of these concepts is that both addition, subtraction, and multiplication are commutative, which is to say it does not matter the order in which you add or subtract things. Now, the straightforward way of doing an example here would simply be to say that x plus a equals a plus x. But that's usually not how it will appear in your Harris courses. More likely you'll have something like 3x minus 9y times 8 plus x. And the professor may just flip it around and do something like this. Similarly, algebra uses the associative properties of addition and multiplication, which is to say that you can do a number of things all in a row, and it does not matter the sequence. More often than not, you'll see this more with multiplication, or it's a problem for people more frequently with multiplication. And more often than not, in Harris classes, it will look something like this, where you might just rearrange things for some reason. Next, we have the distributive property. So the distributive property is simply where you have a coefficient in front of a expression in parentheses, and you are going to distribute that coefficient across the item in parentheses. So it looks like that. Again, in your classes, it's probably going to be something that's a little more complex, where you have something like this, and your professor will just multiply the 3 and the 8 and cancel the z. Next, we're going to talk about two things we use a lot, and we don't name them very often: the identity and inverse properties. So any identity property is simply understanding what it takes to get back the number that you started with. So, for example, under addition, the identity property would be that you add 0 to get the same number back. Under multiplication and division, the identity property would be that you multiply by 1 to get the same value back. A related concept is the idea of an inverse, that if you want to undo addition, you do subtraction. And similarly, if you want to undo multiplication, you do division. And you can see how those are concepts that appear consistently throughout most of algebra. Similarly, it might be helpful to review just a little bit about negatives. The mistakes that I see most often usually have to do with mistakes not recognizing that actually all of these different expressions are the same, that the negative sign is basically an implied multiplication by -1, and so the negative sign can go anywhere in the expression as long as there's one of them, or rather an odd number of them, that those are all equivalent expressions. Similarly, just remembering to correctly cancel out double negative signs is something that gets people into trouble a lot of the time, as does remembering to distribute and cancel double negative signs that appear in that form. Lastly, if you have a coefficient of a negative sign, you have an implied -1 at the front that you treat as a coefficient, and you distribute as you would any coefficient, so that -x plus y is equal to -x minus y. The final topic, and the one that we'll spend the most time on, has to do with handling fractions, and this is the place where we see the most algebra mistakes, and usually it's that folks know the rules for fractions, but don't always apply them consistently. So the first we'll talk about is fractional addition. So if you have a fraction and the denominators on the bottom are the same, you simply add the items on the top and leave the denominator on the bottom the same. So in the form of the type of thing you're likely to see in class, this might look something like this. And because the denominators are the same, we can combine the items on the top. So 8 plus 5 is 13x plus y over the denominator is unchanged. So you can imagine that when you have a fraction that does not have the same denominator, you have to deal with that. So you can't add fractions until you have forced them to have the same denominator. The way that we typically do that is by multiplying each fraction by 1. Now notice that instead of the number 1, I am multiplying it by the denominator from the other fraction over itself. So here the denominator of the other fraction is d, so I've multiplied by d over d. And over here the other fraction's denominator is b, so I'm multiplying by b over b. That allows me to do fraction multiplication, where we take the numerator times the other numerator and the denominator times the other denominator. And similarly for the second fraction, I have d and b, and since db is the same as bd, I am now allowed to combine them like the fraction before, keeping the denominator constant on the bottom. Throughout these video lectures, there will be some practice problems, and I'll tell you when they come up. Use them as you like. For many people, the best approach is to pause the video at this moment, try the problem on your own, and then start the video again and watch how I solve the problem. So I'm going to do a series of practice problems at this point. Use them as you think best suits your needs. So here I'm going to multiply 3x over y by the number 1, which is z over z, so that I am making the denominator be the same for both. And similarly, I want the denominator for the second half to include a y, so I need to multiply by the number 1. So I can do that at any point, at anywhere in the algebraic expression. So I now combine terms. I notice because the first term is xz and the second term is xy, I can't just combine them. If I wanted to simplify this any further, what I would have to do is that I can only pull out the x, and then I have 3z plus 8y times quantity x over zy. So here's another practice problem if you want to pause and work it out on your own. I'm going to multiply the first expression by z over z, so that would make it 3xz squared over yz. I'll multiply the second expression by y over y. I'm going to distribute the y across both terms so that on the bottom I have yz, and then I can combine my terms. 3xz squared plus 8xy squared plus 2y over yz. And notice that there's not really any way to simplify that expression any further. Here's one final practice problem if you want to pause again. So notice here that I have y already in both denominators, so I only need to multiply the first one by 3 over 3 times negative 9 over y, and I can leave the second one the same because my goal is to get the denominators to be the same, 3y, which I've successfully achieved. I multiply 3 times 9 minus 8x. And again, there's really not any way to simplify that expression farther. We've already seen it a little bit, but I think it's worthwhile to mention that multiplication of fractions is actually a lot easier than division or than addition and subtraction. You do not need to force the denominators to be equal. Instead, you simply multiply the numerators and multiply the denominators, and you're done. So in the type of example you're likely to see at Harris, 3x over z times 8x plus 1 over z. You would distribute the 3x, so it would be 3 times 8x squared plus 3x over z times z, which in this case would be 24x squared plus 3x over z squared. So here's another practice problem for you to try out if you want to pause the video at this point. There's several approaches to solving this. You might first notice that you have y on the top and y in the bottom. Because both are going to be multiplied across, you can go ahead and cancel those right away. Similarly, you can cancel the 2 and reduce this 8 to be a 4. And so I will then multiply 4x times 3x plus 1 over 9, and I'll distribute it out. I get 12x squared plus 4x over 9. When it comes to dividing with fractions, the best rule of thumb is that you shouldn't do it. So if you are dealing with dividing by a fraction, you simply remember that dividing by the fraction is the same as multiplying by its reciprocal. So we just pull out that old fraction multiplication and we're done. To give you an example of something more like what you might see in class, you might have something like this that you needed to divide by something like this. And so to do that, I'll just go ahead and distribute the numerator there, and I'm going to multiply by the reciprocal over 3x. You might at this point notice that you can probably cancel the 3x, so I didn't need to distribute, and you're left with x minus 1 over y times z, which you could write like this, or any number of other ways. There's not really a right or a wrong here. All of these are the same expression. So here's a practice problem for you to work out if you want to pause the video. I'm going to take the reciprocal, z over 8x plus 1. Notice that the z's nicely cancel and get negative y over 8x plus 1. Here's another example problem to work through if you want to pause the video. So I'm going to multiply by the reciprocal, negative y over 2x plus 3. I'm going to distribute the negative y, so I get negative 9y squared plus 6xy over, I'll distribute the 2x and get 4x squared plus 6x. The last topic for today is just a reminder of a very useful trick, which is called cross-multiplying. And it happens if you have a fractional equation that looks something like this, you can easily change it to an equation that looks like this. And what you're doing is you multiply both sides by the denominator on the right and by the denominator on the left, and you're left with AD, because the D cancels on the other side, equals CB, because the B cancels on this side. So to make it a more practical kind of an example, you might have something like this, and something like that. So you would cross multiply and get that x squared plus 3x, so we've multiplied that way, is equal to ay times y minus b. So here's a final practice problem for today. Just go ahead and cross multiply this. So to do that, I will just take the x to the other side. I get 9yx times 3x minus 1 equals negative 2x times 7y times 1 minus x. So I've moved that to the other side. We could simplify it further, but that's the easy first result from cross multiplying. If you work it all the way through, you got 27yx squared minus 9yx equals negative 14xy plus 14x squared y. And you can simplify that a bit further, but we can stop there for today. Thanks for listening to the first video lecture, and there are not any online problems for this week. You'll do that after your first video lecture for next week, which should be posted by early in the day on Wednesday.